Okay, this chapter is on the changing tropics. There are some issues that are very specific to the tropics in terms of the high mean SSTs and convection around the tropics, with a few exceptions like the Pacific cold tongue, which only has convection during the El Nino and so on. We will start with the context of the global warming. So this is the global mean temperature anomaly with respect to some base period like 1951 to 1980, and goes from 1880 to almost into 2020. And we have already heard lots of news about how 2016 was the warmest year on record, and then 2020 beat or tied the record despite the reductions in greenhouse gases because of COVID and so on, which goes into how much accumulated carbon there is in the system and how we have already committed to the warming and so on. So these are multiple products which already begins to tell you that even though there are lots of data available around the globe, people are using them, processing them, filling the gaps in the past over time and so on, and producing global mean temperature records and spatial maps as well. And you can see that they are not always exactly the same, but have essentially the same character in terms of all of them having this flat record here from the 1950s into the 1970s almost, and then this accelerated warming over here with a cooler than this baseline before about 1940. So we'll revisit this piece a little bit, and we will also talk a little bit about maybe some potential slowing down or flattening of the warming over here. This obviously doesn't say anything about the spatial patterns, which is shown here. And this is again showing here not a lot of data available in the polar oceans. Despite that, with the data available, you can see a clear pattern of higher warming in the Arctic, which is called a polar amplification, because of the humidity, cloud feedbacks, snow albedo feedbacks, ice albedo feedbacks, and so on. You get an amplification of the warming over the polar oceans. There is some evidence that there is amplification now happening over the Antarctic as well. And then there are dynamic patterns which determine where the warming tends to get amplified compared to the global mean. Of course, these warm desert regions are getting warmer than the rest, and we are going to focus a lot on the oceans, and we'll see more specifically that the Indo-Pacific warming has patterns that relate to the monsoon, and then we have to basically look at the change in what we called before as the warm pool, the area with greater than 28 degrees centigrade sea surface temperatures, because they were critical for organizing convection in the atmosphere, which was part of the Walker cell and the Hadley cell, and of course the northward propagation or northward transport of heat that is needed to stay in equilibrium, given that there is excess energy coming into the tropics and net deficit of energy at higher latitudes. Okay, those are the kind of details. So let's start right away with the tropical warm pool, which is shown here with the waters greater than 29 degrees centigrade, so 28, 28.5 and 29. And this region is typically referred to as the Indo-Pacific warm pool. The Atlantic also has a warm pool, and its warm pool often also goes into the Gulf of Mexico, which you can see has very warm temperatures in August. So this is February and this is August. In February, we know that the sun is to the south, the warm pool is shifted to the south, the SPCZ is strong, the ITCZ shifts to the southward toward the equator, and during August, when sun is to the north, the warm pool shifts to the north, has much larger area in the northern hemisphere, and there is an asymmetry here with warmest temperatures happening in this season than in this season. Wow, depends on convection, because sea surface temperature is going to be affected by convection as well. And we'll see that there has been a debate about whether there is a cap on how warm the sea surface temperatures can get. Are there any processes in the coupled system that prevent the sea surface temperatures from getting too warm above about 30-31 degrees centigrade and so on? Okay. Of course, we know the ITCZ showing up here, very strong in the northern summer, shifted northward when the sun is overhead in the northern hemisphere. Okay. Associated with that, we had seasonal distributions of rainfall. So one of the key things to look for in the changing tropics is to see how the warming corresponds to the rainfall, and whether it does correspond to the rainfall, and how that relates to the circulation changes. So this is called the dynamic response and the thermodynamic response. So the evaporation, humidity, convection, these are kind of the thermodynamic aspects of the response to greenhouse gas increase, for example, or could be natural variability like during the last glacial maximum and the emergence out of that glacial period into the interglacial that we are now in. Nonetheless, we have again seen the JJA monsoon pattern here with the cooling and lack of rainfall on the western Indian Ocean, the ITCZ, and the extension of the rainfall into the northern hemisphere, transitioning during the equinoctial season into the winter solstitial season, and again you can see the shift both southward here and into the southern hemisphere here, and we know that associated with that are the Hadley and Walker circulations, which are also transporting energy across the equator. It is already known that the Indo-Pacific warm pool has been expanding over time. So this is looking at 1900 to 1980, a paper from Roxy Matthew Cole, which appeared in Nature in 2019. This is the news blurb from Climate from NOAA newsletter about that paper. And you can see that clearly the warmest regions have expanded when you compare this period to the more recent decades of 1981 to 2018. This paper focuses on how that affected the Madden-Julian oscillations that we talked about, how they are staying a shorter period over the Indian Ocean and longer period over here in the Western Pacific, Indonesian seas, and so on. Without going into that detail, the key question will be, what does it mean when the region of the oceanic warm pool with sea surface temperatures greater than 28 degrees centigrade increases over time? Does it mean increased rainfall? Does it mean increased convection, stronger circulation, and so on? Those are the key questions that we will try to answer in this chapter on the changing tropics. Okay. There are some interesting dynamic processes that determine the relation between the increased area of the sea surface temperature, warmest sea surface temperatures, convective heating in the atmosphere, and the change of area and intensity of these circulations and convective activity. Okay, that'll be the main focus.